Hello there, everyone. I am Dr. Davis, Dr. Wanda Davis, and I'm going to go over Algorithmic Thinking, Activity 1.1, and Project Lead the Way. So let's get started. So the goals are to create algorithms that use sequencing, draw basic shapes using the Turtle module, use computing for creative expression and problem solving. In this activity, you will need paper and pencil. The instant challenge, I would normally do that outside of class, like if we were in distance learning. But just for example, the instant challenge actually is to open up a software such as Microsoft Paint and draw a picture on your screen using only simple shapes. So if I were to open up Microsoft, I can actually do it in, this is the instant challenge, for example. They said to open it up in Paint. And let's just open it up in Paint. You can also do this activity in Publisher as well. So if I was to select, just say, and I draw a shape. Okay. So what the instant challenge is saying, draw a picture on your screen using only simple shapes. So for example, if you were to do the instant challenge, I drew the picture here on the screen, and I use a simple shape such as a square. And once you draw that picture, it says in the space below, write a number, set instructions for how to recreate your drawing. So if I was to write instructions for this shape, I would first say something like open Paint 3D, and then 2 would be to select the paint brush, and then 3 would be, say, like starting from left to right. Draw a straight line. So, and then 4 would be to, from top to bottom, draw a straight line. And 5 would be from right to left, draw a straight line. And then 6 would be from bottom to top, draw a straight line. And there, as you see, I have created a square over here. So just wanted to share that is the instant challenge. But continuing on, we're not going to do the instant challenge. What we're going to be doing is we're going to do the other challenge. So we're not going to pair up with the student. We're going to follow the instructions exactly. And after this, you would have created some type of drawing. So let's go back here to the exercise. I usually give that instant challenge like if we're at home, if we are still doing virtual learning online, but it's okay if you do it in person as well. So what we're going to do here is we're going to grab a blank piece of paper and a pencil, and I want you to lay your paper horizontally. We're going to fold that paper into 3 equal sections, and your paper will result to looking like this. Okay, so you're going to fold that paper the long way, so it should look something like this. Have it folded like this, have it turned like this instead of like this. And then when you fold it, your paper, when you fold it, it should come out with sections like this. this. Okay, all right. And then what it's doing, it says open the trifold and flip it over. So we're gonna flip the paper over this way. So you see the folds? See the folds? You're gonna flip it over this way and label the top of each section with numbers 3, 2, 1 respectively. So 3, 2, and 1. So when you label it, it's going to look like this, okay? When you label it, there's your 3. And I can make this a little darker so it can show up. So here's your 3. And then there's your 2 in the middle. And then there's your 1. There's your 3, your 2, and then your 1, okay? And then, so we have that. And then it says, so in other words, once it's flipped over, your 1 is going to end up on your right side, as you label it, and your 3 is going to be on your left side, okay? So make sure no one sees your work. Draw a picture on section 1 of the trifold using only simple shapes, such as straight lines, squares, and circles. But we're going to take this even a step further. You can do that. So say, for instance, that you did draw the picture, and you're going to draw this picture on section 1. So if I was to draw my picture on section 1, okay? So I drew my picture on section 1. On section 2, you're going to write a set of instructions how to recreate the picture. So here you would write your instructions, okay, out on how to recreate the picture, okay? So your instructions will be written out here, okay? Similar to the instructions I just showed you when I did the completed it in task. And then it says close the trifold in section 1 first. So close the trifold so that it looks like this. So actually, you're going to close it so that your picture is not visible. So when you close it, so this is the back of it, right, with your steps. See the steps there? That's the back of it. And then, but when you fold it, your picture should not be visible. So if you turn this, you should not see the picture. So now you're going to exchange this piece of paper with a partner in the class. And then the partner is going to go through your steps and try to recreate that picture. As that partner goes through the steps, that partner is creating an algorithm. So an algorithm is basically a set of instructions to carry out a specific task, or a set of instructions to get to the end of, to end with a result, to end with an outcome. So for example, say you want to cook some spaghetti. Well, to do that, you have to have a set of instructions. You already know what it takes to cook the spaghetti, but if you really think about it in a logical way, what steps do you go through to cook the spaghetti? So you write those steps out. Actually, those steps also are on the back of maybe the spaghetti box. That's considered an algorithm because that particular algorithm shows the person carried out a task. It wrote a set of instructions to come up with an end result, which is spaghetti. Okay? So, an algorithm is an ordered set of clearly defined instructions used to accomplish a specific task. So there's algorithms everywhere. You can have algorithms for making lemonade. You can have an algorithm for going to the store from point A to point B. You can have an algorithm for installing an alternator in a car. You can have an algorithm for flying a plane from Florida to Atlanta. So there's all types of algorithms. And then in regards to computers, because algorithms are really relative to computers, You can have algorithm, how do you turn on a computer? You can have algorithms in a computer, how to solve a problem, how to build a database. So it's endless on what algorithms are. So what was the task to be accomplished by the algorithm in the trifold? So you can check your response. The task is for that person, for your partner to be able to come up with the same drawing that you had drawn that you have not shown just by following your set of instructions. So we can check your response. The task was to reproduce the same drawing that was originally created. So there's all types of representations of algorithms, and they can be represented in multiple ways. Most of you will use in this course. So, for example, here's an algorithm. Check the TV source. If you want to troubleshoot TV and cable issues, one, you would check the TV source selector. On the back of the TV, check the input ports. If the cable box is not plugged into the TV, plug it in one of its input ports. Make sure the TV source selected matches the input port, and so on. And then you have, that's in the natural language. Now, what if we were to take this algorithm, okay, so the natural language is the first method of laying out steps of an algorithm, which is an ordered list of steps expressed in natural language, such as English, Spanish, Portuguese, etc. Now, another way to present an algorithm is through flowcharts. And here it is here. So this again, this is the flowchart of the TV. The TV, is the TV working? Yes, it is. Then you can watch TV. If it's not working, is the cable box plugged into the TV? Yes. So if the cable box is plugged into the TV, is the TV source set to same input? Yes. We'll then call customer support if it's not working. If the cable box is not plugged into the TV port, no. Then you need to plug the box into the TV's HDMI port and then set the input to HDMI. But if it is the TV source set to the same input? If it's not, then check the TV input. So flowcharts, this is the way you can present an algorithm as a flowchart. The flowchart's the second method is a flowchart, which is a diagram that shows a sequence of steps using standard shapes such as rectangles to represent actions, rhomboses to represent decisions, and arrows to show the flow of the algorithm. So these are your squares to represent actions, and the rhomboses to represent decisions. So algorithmic thinking is the process of solving problems by identifying the tasks required to solve a problem and using algorithms to clearly describe each task. And you can answer this question on your own. So algorithms to programs. After you are sure of the algorithmic thinking, you can use code segments to develop a program. So what are code segments? To understand the definition of items in an activity, all you do is click on it. Code segments are a collection of program statements that is part of a program. So a collection of the program statements, so in other words, these steps to make the spaghetti, those are code segments. The step to draw the square, those are code segments. So a program is a collection of program statements that performs a specific task when run by a computer. So now, Python and the Turtle module. Python is a program language that we will be using in this class. And what we're going to be doing is a programming language to have some fun with shapes and colors. Like most programming languages, Python offers a comprehensive list of predefined reusable code called modules. So these are reusable codes that have been written by programmers, and it's already built, and all you do is have to plug in certain things to use the code. These codes provide functionality around a specific programming need. So we will use the Turtle module to move an object on the screen and create color drawings in the process. Okay, we will also use this editing editor, and this is called Trinket, the Trinket editor. We will use this to do our Python programming in. So here it says to view the code in the new tab, click the Trinket icon. and select View on Trinket. So to view this code, this is Painter. I put this in here, and you can see what it does. It's going to draw. So it imported the turtle as turtle. The turtle is literally an arrow. It's not literally a turtle, but you can literally get a turtle in there. So painter equals turtle. You're telling it to paint is the same as draw. Painter color, you're telling it you want the turtle to be the color green. Painter dot forward, you're telling it to move, to draw a line forward 100 pixels. And that's exactly what it did. You see it? So it drew a line forward green, and then I also asked it to draw the red. So it drew the red square over the green square. So again, painter dot right means to turn the turtle 90 degrees. Painter dot forward means to move the turtle or to draw a line 100 pixels, and so on, and you end up with a square. So that's what we did in that activity. So remember, painter means like it's the same as like drawing. Okay, color is what it says. You're going to change the color of when you draw it, it's going to draw red. You can choose any colors, okay? When you run a program, you can execute, and I can actually change this to, if I want this to be, say if I want this to be painter dot painter equals turtle dot turtle. And I notice I am recreating this because I'm retyping this because it's going to draw a third square. And I'm going to say painter dot color, single quotes. Let's make this one, let me see, I'm going to get a color that you can kind of brown. Hit enter, and then we say painter, what, forward, right? Because we want it to move forward 100 pixels. We go painter dot right, what, 90 degrees. Now you can put any type of painter dot forward. If you said 120, you can do that. Okay, we're just playing with it. Painter dot right. Say you wanted to turn 120 degrees, so it's going to come away from the square. So let's do that. Let's run it again. And watch what it does. See how my last statement was painter dot right 120. So it didn't turn. It moved forward 120, and then painter dot right 120. So it stopped, right? And then if I go painter, watch this, painter dot forward 100. So when I did forward 120, it actually, let's take this back to 90 because it's going to turn. So it actually went off a little bit, and now we're going to say painter dot forward, painter dot right, like that, and then painter dot forward. So you can actually build your square without, and let's see what it does. See? So it actually kind of drew, but it went up, right? So we can just keep on connecting and connecting, and you can draw so many things with this. So I just wanted to share that with you, how you can, write code to make your computer do something. So when you run a program, you execute the code in it, a line at a time, starting at the top. What does execute mean? To run a program or a single set of instructions. Okay, in a few steps, you will learn what each line does in this program. For now, you can run the program, and we've done that. We've clicked on the View Results. That's that right arrow icon to see what it does as we run the program. When done viewing the steps, you click stop. That's the square icon. Okay, so this is your square. This is to stop a program, and then this is to view the results. That's actually to run the program. When done viewing the results, we click the stop. Click the edit the code, the pencil in the top menu bar to return the code. And also too, if you want to start back from the beginning, you can always do a reset, and it starts it back from the beginning. Okay. Just wanted to point that out as well. Okay, so the turtle object can be hard to see. So the turtle object can be hard to see. You can increase the size of the turtle because, as you saw, it was very small. It was very small. The turtle is small, right? So they're saying that this arrow, which is a turtle, is very small, but you can increase it so that you can make it larger. So it says add the following line of code to the line 4, to change the size. So if I go back to line 4 here, and then here's line 4, okay, they want us to add this to line 4. It should say painter turtle size 3. Add the following line code to line 4 to change the size. Painter turtle size 3. So if we put this on line 4, what it's saying is move that down and go painter dot turtle size, and the size is 3. So we're saying we want the turtle to be a little larger. Now let's play it. Uh-oh. Maybe I made an error. So that's okay. It's good to make the mistakes so that, let's run it again. So I got an error. I'm going to take this line out and let's move this back. It says add painter.turtle size to line 4 to change the size of the turtle, painter turtle, to line 4. So I can try it within this. I don't know. Let's play with this and see. It presents an error. I didn't think we could do that. To line 4. So what if I go this way? Dot turtle size 3. See if we get an error. Okay, so what you need to do is, I'm going to play it over for you again. What needs to happen is you need to put, it says add it to line 4, but really what you need to do is hit enter and then add in, then type this in, all right? In order for your turtle, pardon me, to change to a larger size. See how it changed to a larger size? Now we can also change this to a 2, right? So the first box that it drew, your turtle size is now a 2. Notice that the other turtle sizes are still small. So you would have to add in that turtle, painter turtle size for this. Like that. And then replay this to make your second turtle. See how now your second turtle is larger, but your third turtle is not? So I just wanted to share that. It's actually kind of fun. And it says now, similarly, you can increase the size of the line the turtle draws by changing the size of its pen. Insert a new line of code in your program after line 4 so you have a new line 5. And it's called painter.pen size. So you still go back up, and now let's enter a new line. And let's go painter.pen size. And let's make that a 2 and see what it does. So let's see if the line is going to be thicker. And it is thicker. What if we change this pen size to 3? Okay, we don't have to change them all, but you get to see what happens. That's much thicker. And I know you can tell the difference. This line here is thicker than the other line, okay? Than the other boxes that it drew. So painter pen size. And we're learning a lot of new terminology. Run the program and see and observe it, and we did that. So now it says take a closer look at the code. Notice how the first line of code, import turtle as turtle, imports the turtle module to allow us to use its drawing functionality in the code. What do you think painter equals turtle does? It draws the line. Check your response. It creates a turtle object called painter that looks like an arrow, which it does. And that's what it did. Painter equals turtle. It created the turtle object, okay, and it's an arrow. So this here is an object, okay? Even though you don't see it, it's stating that it's an object. The center of the turtle screen is at X, Y coordinates, 0, 0. So I want you to think of a graph. So when the turtle draws, or when you literally draw, when you're actually having the computer draw on the screen, everything starts from the 0, 0 axis of the X and Y coordinates. Okay? So it's important to understand the difference between the turtle module and the actual turtle object. Right? The turtle module is a Python file that includes predefined reusable code. The turtle object is the painter. Okay, so it's the actual turtle that manipulates on the screen. Okay, what do you think the code painter right 90 does? It turns the turtle 90 degrees. It turns the turtle object clockwise 90 degrees. Okay, the line of code called when underscore screen, when equals turtle dot screen, it saves a turtle screen object called when, giving the program a way to control screen level behavior such as when to close the turtle program. Finally, so this tells you when to close. When you get to this point after the drawing and the turtle gets down to this point, it's saying, okay, we're getting ready to close this program. Okay? And then when it gets down to the when main loop, it actually stops or it exits the program. So just like it says here, the when.main loop is used to keep the turtle screen from exiting once the program is complete. So the turtle, in other words, here, the turtle stops. It doesn't exit off the screen, and that is the purpose of the when main loop. It stops at the end of the last set of algorithm, okay, or instructions. Okay. And so, as you can see, the turtle used the traditional coordinate plane with center at 0, 0, the y-axis and the x-axis. When a turtle is rendered on your screen, it starts at this location. It starts right here in the center, facing in the positive x direction. So it faces going to the right. This initial heading is referred to as a heading of 0 degrees and turns. Turtles can turn 360 degrees. Now that you know a bit more about how turtle program works, you can modify its behavior and add some functionality. Change the value in the parentheses. You can play with forward, right, and all of that. Turtle size, pen size. You can go through these definitions. Instructions for the turtles are called methods, okay? And methods are predefined set of instructions. The symbol is called the dot operator and indicates that the method of the turtle is being called. Methods can move forward, right, left, backwards, and so on. Let's see, put another way, your turtle object painter has method forward and another method right. Method is calling an action, telling it to do something that you can use to control its behavior. Additionally, each of these particular methods have parameters. And a parameter is a value you can give the method to specify, like the value of 90, the value of 100, a value of 120, and so on. So here there are many methods for a turtle. Then you see thus far, review some of the methods. So these are some of your methods for the turtle, okay? I'm going to actually copy and paste this because I want to put this on some of my these are just for, let's put it down here. So I keep extra notes myself. Okay, put that in there. And these here are just what it says. These are this here, additional turtle methods. And these are good. I keep these for my students. This helps with, okay, many more methods. Get this out. Okay, that's what that is. Take that out. So just moving on down, and then it says 16, painter.circle. All methods must reference a turtle object. For example, painter.circle. That means if I was to go up here, like say if I go painter.circle 20, and then if I run this, it draws a circle, a circle with a 20-degree radius, okay? Well, what if I was to say painter.circle, and let's do 40 and draw it. I did not pick my pen up or take my pen down, right? What if I say painter.circle at 60? What's going to happen? It just continues to draw above the original circle. So as you can see, okay, the first circle it drew was painter.20. The second circle it drew was painter.circle. I'm sorry, 40. And the third one is painter.60. So as mentioned earlier, and then there's some other painters. Painter.forward D moves the turtle in the direction it faces. Painter.backward moves the turtle backward. Painter.right turns the turtle to the right by so many degrees. Left turns the turtle left, and so on. .circle draws a circle with a radius of 20. .go to moves the turtle to a particular location. So if I go up here and I say, say if I'm down here and I come right here and I'll say painter.go to. Now let's make sure that go to wasn't, okay, it's all one word. So it's all one word, like go to, or we can have so much fun with this. The first number that you put in is the x-axis. So let's say 50, and then let's do it and see what it does with this last circle. I got an error. So something here I did wrong, and I will check it out because I have to do probably a pin up and a pin down to for that to take place. So up here it talked about set the heading. It sets the direction the turtle is facing to give value, and these methods are so important because this is how you create different things. Tell the computer to create different things. Painter.pen color changes the pen color. Painter.pen up, it lifts the pen off the canvas so you can then move the turtle to another position without making a line on the canvas. Pen down places the pen back on the canvas so you can resume drawing. Pen size sets the pen size, and the turtle size sets the turtle size. So I am going to get back to that go to, okay? So just continuing on. Once you are comfortable with using different turtle methods, use the code editor above to draw the picture you created in the trifold at the beginning of this activity. Share your work. And then also make sure that you complete the conclusion. So this is Dr. Wanda Davis, and I went over activity 1.1 with you, Algorithmic Thinking, and I'm looking forward to going over many more activities with you using Python programming. Have a good one.